Welcome to part 6 of Competency 4. In this video, we will work with applications of arithmetic and geometric sequences. Okay, for the first two problems, we're going to work with simple interest. We have two formulas version of the formula that we can use. My favorite is P plus PRT, and the reason I like that, it's the same as saying principal plus interest because interest is equal to PRT. It's just easier for me to remember. You can use the other formula. It's up to you how you remember it and what you want to use. However, we do need to point out that there is a connection between simple interest and your arithmetic sequences. Your A sub 1 is your principal. Your common difference is your principal times the rate. And your time is actually your n minus 1. Okay? That's your nth term, whatever term you're at, whatever year minus 1. But we're not using that. We're using our specialized formula for simple interest. And it is simple to remember. So let's look at number 1. If 200 is deposited into a bank in which the annual simple interest rate is 4.5%, what is the amount after 9 years? Okay, first we need to take our 4.5 and that needs to be changed to a decimal, and that is 0.045 for our rate. Okay, and of course, 200 is our P, and of course, the amount that we're looking for is our capital A, and this is our time. So what do we have? We have A equals 200 plus 200 times 0.045 times the 9 years. So that's just putting it in the calculator. So that's 200 plus 200 times 0.045 times 9. Double check our entry and push enter. $281. Okay, let's keep going to number 2, which will be slightly different. Okay, if $350 is deposited into a bank in which the amount becomes $402.50 after 2.5 years, what is the annual interest rate? Okay, so 350 will be our P, and then, of course, this will be our A, the 402.5, and then this is our time. So the interest rate, we are going to call that X, okay? And before we begin, we need to look at our mode. Make sure, I'm going to come down here. See where I've highlighted? Make sure that you have that selected and that is not over here on sequence. If you worked in a prior video with me and you were working along, you would have your calculator in sequence mode. We're not doing that for this question. Okay, so let's go second mode to back out of that. We need math. Arrow up. We need the numeric solver. Push enter, and let's clear that out. Okay, what do we have? We have 402.5 equals 350 plus 350 times, we don't know rate, that'll be X, and then times 2.5 years. You know what? Let's go ahead and enter the half. So in case you haven't done any other videos with me, so you see how to enter fractions. Okay, so we will start with the left-hand side. That's 402.5. Push enter and clear it out, or you can type over, your choice. So 350 plus 350 times the x, I don't know, times, oh, now we need to go alpha y equals, and we need number 2. That's a mixed number. Now we have a setup for a mixed number. So push 2 again because we want 2.5 years. Arrow over, put in your 1, arrow down, put in your 2. Now, we will push OK. We do that by pushing the graph button. However, we're going to have to push it twice. So push it the first time. That isn't the answer. And how do I know that's not the answer? We don't have the bullet that's going to show up below it. So I'm going to push it again where it says solve. See, first it said OK. Now it says solve. So I push enter. And now we know we're done. Okay. And that is our interest rate. Now, this is rounded. And if you round that, that will round. Well, basically, you're also going to have to move the 0 over. So that is going to be 0.06, which becomes 6%. Okay, and that will be the value. All right. And if you look at your options and you think about it, that would be the only one that would satisfy option B. Okay, let's move to number 3. Quick note before we move on. You may see here, well, you can see here that I have number 2, the prior question, entered in a different way using the other formula of simple interest. And notice it still rounds. Your handheld calculator may actually say 0.06. Okay. For some reason, it's different on my emulator than it is on the handheld calculator. I've looked into this and haven't got an answer. So if you got 0.06, you are correct. And obviously, that was the answer for number 2. All right. However, for the next several questions, we are going to work with compound interest, and there's an explanation of how it would look in a series, and this is our formula. Okay. However, we will not use the formula. The formula will be given to you on the formula sheet for the TExES exam, but we're going to use our finance app in our TI-84 for this. All right, so let's begin with number 3. Okay, if $600 is deposited into a bank in which the interest rate is 8% compounded quarterly, now that's important. Okay, what is the amount after 5 years? And remember, we need quarterly. Okay, so we're going to push app. And we want number 1, finance. Enter. And it's the TVM Solver. Enter. Now, I have been doing some other calculations here. We're just going to type over that. All right. What do we need? First, N is always that's your total compounding. And that is going to be your number of times compounded times the years. For this situation, that's quarterly, which is 4. That's 4 times the 5 equals 20. So N will be 20. Here, let me get rid of that so we can see. Okay, so we're going to enter 20 for our N. And then we go down to interest. You do not change it to a decimal. You just type it in as you see it, 8%. Now, we go down to our present value. PV means where we started with. That would be our initial deposit, which is 600. Enter. We don't have any payments going in or out in between, so we just leave that as 0. For a lot of questions, that'll be left at 0. Future value is what we're looking for. Temporarily put a 0 in there, that's a placeholder. Now we need to go down. The PY and CY need to be 4. Now this is what's kind of interesting. Push 4 for quarterly, and then I'm going to arrow up and it pops 4 into the CY for me, and that's compounded yearly. It just does it for me. And next, this is just a setup you have to get used to. Now you're going to see something happen with the future value, okay? How do you get your answer? Well, you push alpha, enter, and there it is. But notice there's a negative in front of it. There is a programming reason why that's there. I'm not going to get into that. You can look that up for yourself. But we do see a rounded option. C is what we need, $891.57. Remember, for money, you need to go to the nearest penny. That isn't always how the questions are stated, but that's just proper. It's either going to, well, if you're an accounting major, naturally it has to be the nearest penny. But for mathematics, sometimes they ask for the nearest dollar amount. They may change it up, but just go with penny for in most cases. Make that the default, okay? All right, number 4. A person needs $5,000 in 3 years to help pay off a car loan. To the nearest dollar, how much money should be deposited into a bank in which the interest rate is 10% compounded monthly? Okay, monthly is 12. So that means our total number of compounding will be 3 times the 12, which equals a total of 36 times it's going to be compounded. And our FV, future value, has to be the 5,000. Okay. And remember, you do not change the percentage. All right. So let's go back and just start at the top. Okay. Our N, that needs to be 36. Our interest was 10. Okay. Now our present value is what we're looking for. It says, how much do we need? We need 5,000 in the future. So how much do we need to put in the bank right now? We don't know. And remember the payment, the PMT, you're going to have to arrow down for that. Leave that at 0 too. Now, future value. Now, here's the thing. You can put a negative there or you cannot put a negative. It's just one of them has to be negative, the present value or the future value. It's your choice. So let's go ahead and just put 5,000 and it will show up in a minute. Okay, now we need to put in 12 down here for the PY and the CY. So put in 12, arrow up, it populates for us. Now, we don't want beginning. I've noticed that this doesn't exactly make a difference unless you're dealing with a PMT. But if it makes you feel better, you can say, okay, we're looking for the beginning value. I've played around with it until you start changing this payment amount. You have payments during the year. It's not really going to affect it. Okay, so we're going to go up and we want to see the PV. How much will we need to deposit now? So push alpha, enter, and there it is. Now remember, it said to the nearest dollar right here. So which option? Obviously, A is not it, B is not it. The only one that's even close is C. Okay, now do notice that negative popped up for us. Okay, and yes, it does round to a 9 because obviously 6 is going to round up. Okay, all right, now let's go to number 5. Number 5, if the annual rate of inflation is 4.4 and the annual rate of interest is compounded continuously, what will be the value of $2,000 in 12 years to the nearest dollar? Okay, so we've got our time, and this is our PV. We're looking for the FV. There's our interest rate. Now, let's go to our calculator. Just in case you didn't remember how to get there to our finance, you need apps, and it's simply number one. You push enter, and there you go. We need the TVM Solver. Enter again. Now, what is our N? Now, everything changed the minute. Here, let me highlight this. Oops. Ooh, that was weird. Okay. That was very odd. All right. Compounding continuously changes things. This is what I need you to do. Go ahead and just put in your 12. And when we get down to the bottom, I'll explain to you why we're not doing it 12 times. Well, we have no yearly compounding. There's no monthly, if you noticed, there's no months, so there's no 12. And the other one question we had was quarterly. That would be 4. We can't use that. So let's just enter everything, and then we'll fix it down here at the bottom. Okay, interest 4.4. Now enter that. Now, our present value is the 2,000. Remember, we don't worry about the negative. That will pop in on its own. We don't have payments. We need future value, but we're going to put a 0 placeholder. Now, this is where things change. I'm going to say, for the year, your PY, make that 1. Enter. See where now we're on our CY. You can change CY, but I want you to make it that's compounded yearly. We're going to make it a very high, crazy number. So this is what I need you to enter. Oops. 10 to the 11. And it's going to pop in 1E11. Okay? 10, carry it up, 11. Push enter. And I'm going to highlight N for the fun of it. Now, what that's going to tell our calculator, it's going to like trick the calculator, and it's just going to put a bunch of compounding in there for us, okay? Now, we can go up. It's just a little way to get it's a trick to trick the calculator into doing what we want it to, okay? Think of it that way. All right, alpha, enter. Notice that we're on future value, FV, and enter. And that is our answer. Notice you didn't have to worry about the negative because you need one of them to be negative, either the PV or the FV. Doesn't matter which one. And if it pops up on its own, that's fine. Okay. The option is C. Now let's look at number 6. Okay, which will be the same thing. Okay. I see it right here. It says compounding. Oops. I was going to highlight that. There it is. Okay. If the annual rate of inflation is 3% and the annual rate of interest is compounded continuously, in how many years, so we're looking for years this time, will $1,500 grow to $4,500 to the nearest tenth of a year? Okay, well, I'm looking at my options, so it's just 0.1. Okay, so this is what we need to do. I'm going to go all the way back up. We're looking for years. So remember, our number of our capital N, number of times compounding, we're just using 12, I mean, not 12, but just the years, just the time. Okay, so it's going to be this 1 times the years, and we don't know the years, so that's just 0 placeholder. Then we go down, and our interest is just 3. Now, our present value, we started the 1,500. Okay, and you know what? I'm going to do something. I'm going to put negative 1,500 there. You have to use the negative symbol. Don't use a subtraction. Then you arrow down, and I'm going to type over that and say 4500. Remember, I said at least one of them needs to be negative, okay? Now, we have everything set up for compounding. So we go back up to our n to find our years. So alpha, enter, and there it is. And I see A is the option we're looking for. Okay. I've always liked this. I think it's clever that we can, you know, put in something to kind of trick the calculator. Okay. All right. Number 7. Assume the annual rate of interest is compounded continuously. At what interest rate will $900 grow to 3,800 in a period of 20 years to the nearest tenth of a percent? That was kind of clumsy. It's just the way it's written. I had to think about it for a second, but this is what we need to do. We need to put in our 20 years for our capital N, but we don't know the interest. So put in a 0 placeholder, and now let's go enter everything. I'm going to say negative. You know what? Let's not do that. Let's try 900. Okay, remember, we don't mess with the PMT. Now, our future value, we're going to say negative 3800. We're going to make future negative this time. Okay, and we don't mess with the bottom because the 1 and 1e to the 11 is our setup that we need. Now we're going to go up to where it says interest and get rid of that 0 and say alpha, enter, and there's our value. And notice it didn't matter which one of these, the PV or the FV, was a negative, as long as you make one of them negative. Okay, so that is option C, 7.2. Okay, this is the last question in this particular video. I hope you learned a little bit about how to, what to enter in, how to tweak to get your interest, your compounded, and your simple. Thank you very much for watching and watching us all the way to the end. And especially a super big thanks to everybody who has subscribed and liked our videos and shared our videos. You don't know how much it is appreciated. I wish everyone happy testing.